So today we're going to review Fstrings and the dot format method. And we'll just start out with this today, and we'll review accumulators as well. So starting off with Fstrings, Fstrings and dot format, these are two different ways of doing exactly the same thing. So that we have the dot format method, and we have Fstrings. I believe Fstrings are just syntactic sugar on dot format, so they're going to work exactly the same way. Well, you'll see. There's a slight difference. Fstrings sort of just give us slightly aesthetically cleaner code, and dot format is what it actually turns into when it's parsed by the interpreter. Yeah, let's just jump into Fstrings. So I've given this example before, and we can look at this example here too. Let's just look at this example. Let's start off with this. Oh, I'm sorry. I know I made my text a little smaller today. I prefer it at this size, but I just want to make sure if everybody else can see it. Oops, sorry, let me pull this up here. If anybody needs me to increase the size of my text, just put it in Slack and I'll see it. So it is a little bit smaller today. But I like to do this because I can just have more code on screen. So, okay. Cool. So in this example, var1, var2 are these two integers, and we have this f string. So let's look at this. We've got this f string. It's just a regular string that starts with f, and then everything inside curly brackets. Notice if I delete this f, the highlighting changes, right? So if I delete the f, this all just turns green, and I'm just literally going to get this string with the curly brackets and the vars and all. If I throw an f in front of it, everything in the curly brackets is just code that's going to be evaluated for whatever it is, right? So whatever is expressed within, whatever values are expressed within the curly brackets is going to be what turned into a string and then formatted into the f string. And the dot format method is really just a slight variation on this. So we can do this on a regular string, and we can say dot format, and we'll just cut these out, and we can just have empty curly brackets like this, and then we'll pass in the arguments into dot format. Like this, right? So the first argument will be templated or formatted into the first set of curly brackets. The second argument will be templated into formatted into the second set of curly brackets. Sorry, I keep using the word template. I learned these as template strings. In JavaScript, they're called template strings. So when I learned f strings, I learned them as template strings, but they work exactly the same way. So sometimes I use the word template when I mean format. So excuse me for that. But yeah, so these two lines, what's now lines 7 and 8 right here that I have highlighted, these look a little different, but they are exactly the same. Yeah, so I prefer f strings like this. Just throw an f in front of it and template in the variables directly in. I believe Tovio, as per a conversation I had with Tovio a while ago, said that they prefer the dot format method like this. So, you can pick whichever one you like. But yeah, I like Fstrings. I think they're a little shorter, a little cleaner. I was actually working with somebody earlier today, and I remembered there's a feature of Fstrings that I forgot, which is, we're not going to dive into this too much, but you will see stuff like this. So we can do various formatting to the string like this. So you see this :4D is going to leave a space in front of however many spaces I say to leave in front of it. It's going to leave. So I forget exactly what D does. I didn't have time today to look back into the various formatting options, and we're not going to be going over those formatting options. But I wanted to mention that you will see some stuff sometimes, like additional like colon, and then there'll be some number, just some little substring of characters there, and that is for the sake of giving you formatting options. There are various things you can do there. So if you see that, at least what it's doing. It's just there to, in some way, like beautify the string or standardize it. Just make it a little bit cleaner and a little bit nicer looking. But yeah, like I said, we're not going to be going into that today. But if you see it, you at least know what it is. So. And I'll try to look up a resource for those things, because they're actually, I do want to put them in our material. But yeah, I was working with somebody just a little earlier today and just figured I'd mention that. Okay. So this is just saying you can still use the dot format method, but Fstrings are generally, quote, preferable. I think they're considered more Pythonic. I'm not personally a big fan of doing things that are Pythonic because they're Pythonic. I think do them because they make sense. In this case, I agree with, and in most cases, I tend to agree with what is considered Pythonic. I tend to think that it standardizes a really good way of coding. So yeah, you can pick whichever way is preferable to you, but just know that they are equivalent. Cool. Cool. So I'll leave it open to any questions on Fstrings. Feel free to put those in if you've got them. But for now, we're going to move on into accumulators. Okay, so an accumulator can be thought of as a running total that is held in a variable. So we will tend to talk about accumulators as related to one of the types that we've talked about. So we'll talk about, we've talked about ints and floats and strings and lists. So we'll talk about integer accumulators or float accumulators. A lot of times with ints and floats, it doesn't really matter. They're just numbers, right? So we might talk about a numeric accumulator or a counter or a sum accumulator or a product accumulator. And those are all various forms of numeric accumulators, right? Where we're counting things or accumulating things in numbers in some certain way. We'll talk about an accumulator in terms of its type, like there are string accumulators and list accumulators. I would say probably most commonly, I don't know if it's ethical to say that there's a most common or more common types, but it seems to me that I tend to use numeric accumulators, list accumulators, and string accumulators a lot. Occasionally I use dictionary accumulators. I don't as often use set accumulators, although I have. Tuple accumulation I really like personally as an alternative to lists. I like it, but I don't really use it that often because Lists are pretty standard, and most of the coding I'm doing is being presented in some way. So yeah, so I would say you can kind of focus in on lists, strings, and numeric accumulation as sort of your main basis, and then dictionaries are important to know, and they come with a little time. So okay, so the accumulator pattern, and this is a very generalized pattern, right? We initiate the accumulator variable, we repeat some process, and during the repetition of that process, modify the accumulator accordingly. So I like this language here, to modify the accumulator. Modify means to change it in some way. Sometimes that change is an accumulation. I think of accumulator, the word accumulator, as being very much like additive, like where you're adding something. But some people will talk about a decrementation pattern, where maybe you're subtracting a number, or you're removing elements from a list. I just, the word accumulator kind of gets used as a catch-all, and that's the way that I like to use it. So whether we're adding things or subtracting things or manipulating a value in some other way, an accumulator sort of has this form, like var equals val of some sort. Let's just say, I don't know, var equals val. We initialize some variable, repeat some loop for L in collection var dot modify L or whatever. I don't know. So it's something like this. Obviously, this is not valid code. Val and collection are not defined. Modify is not a method. So this is just pseudocode right here. But your accumulator patterns look something like this. They're going to look. They can be much larger than this. They can have. We could have multiple accumulators. We could have multiple conditions in here. We might even have an accumulator within an accumulator. That's a thing. We could have list 1 equals list, and list 2 equals list, or excuse me, like this. And then for J and something like that, like this, right? So you will see this pattern sometimes, where we have just, this to me looks like an accumulator inside of an accumulator, right? So there's sort of a, I don't know, kind of a shape to it, to this code that you learn to recognize. But basically, we have some target, and that target is usually initialized as empty. Not in all cases will that be so, but usually for an additive accumulator, we'll usually almost always initialize an empty target up here. And then we loop through some collection, and I'm going to just stick with for loops for these examples. Loop through some collection, and a collection is just any iterable type. I should probably really call this an iterable. Any iterable type. So we iterate, and in the process of iterating, we at some point will modify our targets. However, in whatever form that target can be modified, which is defined by its type, right? So if it's a list, we might append, we might remove, we might pop from it, we might insert elements, whatever, so those kinds of things. So I would say any problem that sort of fits that definition, I would consider an accumulator pattern problem. Okay. So some accumulator is using ints and floats. So, I mean, this is basically what I just showed. I was showing it with lists, but, this code, I think this code looks pretty similar. Empty variable for element in list of elements, num plus equals element. So this is going to sum all of the numbers in this list. This is the same. It happens that this particular code is the same as just running sum of list of numbers like this. It's not going to run because we don't have list of numbers defined. Cool. All right. So here we go. Let me jump into the plain text. I don't use the plain text as much as I want to. This is nice because it's formatted in Markdown, and Slack messages are also formatted in Markdown, which makes it kind of easy. Of course, it's not going to actually render, though. Oh, that's convenient. Oh, okay. Is that going to render? Oh, it doesn't even render. Okay. Well, ostensibly, Slack messages are formatted in Markdown unless you paste in the stuff. I don't know why it's not formatting. Oh well. Yeah, that should be clear. Cool, and I'll put 4 minutes on the clock. Y'all can get started. Okay, go ahead and put in your answers. And I'm going to, oh, wait. Okay, cool. I'm going to paste in the provided answer here. Cool. So string accumulators, we can concatenate strings, a string by using a string type accumulator. So there's a really similar pattern for tuples. I showed this a little bit when we talked about tuples. I've spoken with a number of students who have expressed some confusion lately regarding tuples. So this is, I mean, to be clear, this is regarding strings. But since this works similarly, I want to talk about tuples here for a second. And hopefully this will also drive home, the concatenation mechanic that's built into Python like this. So, yeah, let's do let's say string. We'll show this with a string. And so string plus hello, right? So string equals, so if I type, or if I print, excuse me, if I print string plus hello, string is empty, hello is hello, we get hello. If I say string equals string plus hello, and then hello, hello, right? String plus hello equals hello, hello. String plus space plus world is hello world. So if I string plus string plus space plus hello world, da da da. So now if I print string hello world, okay. So again, we can use the plus equals operators here, plus equals, and that's syntactic sugar for what we just looked at, right? So this string plus equals hello, string plus equals space plus world is syntactic sugar for this, meaning that these are identical ways of doing it. Python takes the plus equals way and it turns it into this. Okay. So this is kind of like, you might notice, kind of like an append, right? It's kind of like we're appending the elements onto string. Like this. String equals empty string, string plus hello, string plus space, string plus world, right? So this behavior is somewhat like append. Since we're talking about this, print ID of the string after I create it. So pop quiz. What's the ID of the string after I add hello and space and world? Is it the same ID or is it different? Immutable. Nice. Yeah, okay, cool. Yeah, so it's a different ID. So it seems like, I mean, is there, so let me ask this. Is there anybody that doesn't understand that this is a different ID, or doesn't understand what I mean by ID? I know I'm asking you to put yourself on the spot a little bit, but if you feel comfortable putting yourself on the spot, you know, you can bring it up now and we can go over this, because this is a worthwhile topic to go over. Because immutability is a weird one and it's an important one. Okay, I'm not seeing anything. Seems like I'm getting the sense that there's a lot of parity and understanding around this. So yeah, so strings, every time we concatenate, you know, even, you know, hello plus world, like this, right? This string has an ID, this string has an ID, and the concatenated string has yet another ID, right? So there are 3 objects that live in memory for this line of code, which gives us a simple type that with reassigning to the variable like this allows us to sort of mimic a lot of mutable behaviors while still having the safety and predictability of a mutable or of an immutable type, right? So yeah, there is potentially there's you know, since you're duplicating objects in memory, there's the potential for I don't know if you'd call it a memory leak, but a there's potential for using more memory in certain circumstances, not in all circumstances though, because immutable types are also simpler, and for the same amount of data they take up less memory because they don't need to be mutable, so they're simpler to represent in your memory. Okay, cool. So this behavior works with strings, but it could also work with tuples. And this is why I wanted to dive down this rabbit hole. Single element tuples. Remember, single element tuples have to have a comma. It's kind of weird. I always look at it, and even in my own code, I'm like, oh, that looks like a typo. You know, my first thought is like, why is this comma just dangling there? But it does need to be there, unfortunately. Let's call this tup. Okay, so tup equals empty tup. We'll print the ID of tup. The ID is going to behave the same. We don't need to go through the ID thing again. Tuples are immutable, right? So this is sort of tantamount to an append for a tuple, even though obviously we get a different object every time. So hello, space, and world. We don't need the space. Cool. Okay. On to our string breakout. All right, go ahead and pop in your answers. Cool. Okay, go ahead and keep your answers coming in if you've got anything, or just whatever you've got. So write a function called build non-vowel stir that takes in a string and returns the string accumulator that accumulates all non-vowels. So for this one, we're going to just create a new string for char in the old string. If char.lower in AEIOU, and this is kind of silly. You don't actually have to, you can do checks for membership across strings. You don't have to do, always do a list like this. We could just do this. So if char.lower in AEIOU, continue else this, and shoot, you know, I'd probably just do this, not in that. So as long as char is not in this string of AEIOU, oops, and I gotta delete that ending one, then we'll accumulate it, and then we'll return new string once it's all done. Cool. All right, another breakout. So I'm gonna write this up like a test, the example. You can use this to test your code. So what this test is saying, and I mean, I code like this all the time, so you're probably used to seeing this kind of thing, but what this test is saying is print out whatever this function collect evens returns with that list as its input, and then after the comment, it just says the string of 24. So that's just our expectation, what we expect it to return for that input. And you got 4 minutes on the clock. Okay, go ahead and put in what you got. Okay. Write a function called collect evens that takes a list of integers. The function should return a string that accumulates the even numbers into the string. So we've got a little bit of casting to do. So we'll say, let's call this text equals an empty string. And we'll say for num in list, if num mod 2 equals 0, then it's even. And we'll text plus equals stir num and return text. Cool. It looks like that's where people are at with this. That's what I'm seeing. Few answers. List accumulators. All right. We've got a few here. There we go. That. Oh wait, what am I doing? I'm pasting this in like it's another breakout, and it's not another breakout. Sorry. Cool. Well, let's see. Somebody's saying their code's not working. I see you doing if num divided by 2 equals 0. So I would say, yeah, you want to get the remainder, which is the modulo operator. Other than that, your solution looks pretty good. Yep, there you go. Somebody beat me to that. Cool. Good. All right, so list accumulators. Sometimes you need an accumulator that's an empty list. As the for loop gets evaluated, the accumulator will be appended with the new values, syntax, empty thing. Here's our loop, your code, and your alteration to your target. Cool. Okay. We'll get 4 minutes on the clock. Go ahead and get your answers in. Sorry, I just saw somebody made a comment. It is only showing up on Slack on my computer, not on my phone. I don't know why, so I apologize that I missed your comment, but or your question. The question was, are you giving us the list of letters, or do we just make it up? Yeah, just make it up. Sorry about that. Sorry to leave you hanging. I don't know why it didn't. That message didn't propagate on my phone. Okay. So, you know, the trick here is just checking this check from membership of the beginning letter of the word, which is word sub-0, and then the dot lower. This is a really common trick, a really common thing to do to sort of ignore case, because a lot of, I mean, to you and I, if I say A equals A, we're like, yeah, these are the same letter. We know these as the same letter, but to Python, this is going to be false every time. These do not equate in any way, shape, or form, other than that they're both strings. However, you know, if I say dot lower, then I can be assured that this is guaranteed to be the lowercase version of whatever that is. So if you call dot lower on a lowercase letter, it's not going to matter. It'll still give you the dot lower. It won't give you an error or anything. So that's just a way of standardizing that. It can be useful. Cool. We have a request that I talk a little bit about split. Yeah, so split is one of the ways of converting a list, or excuse me, a string to a list. So if I'm going to talk about split, I should also talk about join. So split and join go together. You can think about one sort of undoes the operation of the other. So I said that split is one of the ways of converting a list or a string to a list. I made the same error last time as well. So one way here, let me get a string. Let's go into my notes document here. And I'm just going to use this little sample text that I have. There we go. So split is one of the ways of converting a string to a list. I did it that time. The other way is list, but the results are very different. List is going to take in like whatever it can convert to a list. There are various types that can be converted to a list. But the list function, if it takes in a string, it's going to give us a list of all of the characters in the string, where each character is its own individual element, right? So notice this is every single character as its own element in the string. A lot of times we want to take a string and like analyze it in chunks that are meaningful to us. Often those chunks are delimited in the way that we write here. And actually, let me pull in the punctuation version, right? So often we delimit those chunks explicitly with punctuation or with other things, whatever. So Like if I wanted a list of sentences, I could say text.split on period. And this is going to give me a list where each element is delimited by the period character, right? So this is going to be give me a list of sentences because I said, hey, go find every period, and every time you find a new period, use that as a separator to make a new element in the list, right? So in this case, we have one. I think we just have two sentences. Yeah, it looks like we just have two sentences, and then there's a new line character here because there's a space or a new line character there. If I could add a few more, and there's a few more new lines, but yeah. Quite often the way we want to deal with the text is as a list of words. So if I wanted a list of the words, what you do is you just don't pass anything into split. And if you don't pass anything to split, it's going to split on new lines, tabs, and and space, right? So there are three what's called white space characters. They're three different characters. They have different ASCII representations, three separate characters, and it's new lines, tabs, and spaces. And we call them white space just because they're space. They're characters that we would see as not there. So they're just empty. Cool. So notice those new lines are gone. The previous example had those \n characters. That's a new line character. It's the visualized version of a new line character. Those are gone. So this just gives us words. Now, this does have punctuation in it, right? So notice snow period is a word according to this system, so it doesn't filter out punctuation. If you want to filter out punctuation, you have to do that yourself. It also doesn't standardize case. If I wanted to do that, I might do text.lower .split, and this will give me a lowercase version of the text, and this will .split it. Cool. Still have punctuation in there. So that's what split does. Now it's worth mentioning that join, let's do this, words equals text dot lower dot split. So if let's say I do something to this list of words, I don't know, maybe I accumulate all the words that start with a vowel, although I see one. That wouldn't be that interesting. Maybe, yeah, so let's say I do something to the words, or I do something to this list of words, and I want to turn it back into a string. I can use the join method. So we'll do this. We'll make this text again. We'll say words. Oh, excuse me. So we'll say string dot join words. Now this is a bit of a weird one. It's not often that we call a method on a literal like this. This is a string literal. A literal is some value in your written code that evaluates to itself, right? 4 equals 10 is not a literal. It's an expression that evaluates to false, right? False is a literal. So if I write false with a capital F like this, this is literally false. It evaluates to what I see. This does not evaluate to what I see. What I see is 4 equals 10. It evaluates to false. A equals 10, where A is some variable. I don't know what it evaluates to. I don't know the state of A because I don't have it written here. But But depending on the state of A, this is a Boolean, either true or false, right? So a string literal is what's in the quotes, or not in the quotes in this case. So this is an empty string literal. It's not often that we call methods on literals as much. I mean, you tend to see it on something that expresses a literal, right? Or I don't know why I said that. Something that expresses a value. So this expresses a lowercase version of this string, right? Text expresses the string assigned to it, but it's also not a literal, right? Text is a variable that expresses that value. The value in this case is a literal, right? So it's more usual that we'll see this, but in the case of join, we almost always will call it on a string literal directly. So it makes it kind of look funky. It's important to note that even though split and join kind of look different because we usually call join on a literal, they're both methods of strings and not lists. So yeah. So join takes a list and it joins it into this string with this, whatever is in this string, as a separator, right? So if I wanted to triple dash, oh, that's T triple dash, whatever, it would separate that. Yeah, so we can join on whatever. I know you said never mind, but the answer is yes, we can join on with anything we want, right? So if I wanted to join with an at, so this is just the separator. Oops, this is the separator, and it's gonna be the thing in the. Oops, I'm like, why is it not printing? TXT. We'll print text there. Right, so now there's an at separating what was every element in words. Usually you'll see string with a space in it dot join, right? So you do stand to potentially lose some information here, but that's okay. Notice we lost the new lines, and there aren't any tab characters in here, but if there were, we would have lost those as well. Cool. All right. I'm hoping, I just kind of mused about split a little bit. Oh, we got a thanks in there. Good. Is my audio okay? Is my audio okay? Oh, it was just you. Okay. Seems good. All right. I'm just worried about that, if that's like a deeper issue. If okay. If my audio is bad, do put something in there, or let me know in some way, because obviously we gotta keep this good. So okay, cool. We got another breakout. Oops. Sorry, folks. We're a little past halfway. Let's have a 5-minute break. Let's reconvene at 16 minutes after the hour. All right. Let's get back into things. Cool. So we've got another breakout. And I'll put 4 minutes on the clock. Okay. It looks good. Go ahead and get in your answers. Cool. So for this, our accumulator, our output, for I in our input, which is a list, and then we just have some type checking control flow. We check if I is a float, a string, or an int. So if it's a float, we turn it into a string. Elif it's a string, we get its length. Elif it's not an integer, any other type other than an integer, then we're going to append it. And then if it is an integer, it's just not going to get appended. At least in that form. Appending the length of the string will append as an integer. So if there's strings, you'll see integers in the output. Right, dictionary accumulator. So dictionary accumulators are a little tricky. There's this thing, let's see. Oh, wait, we got a code along. This is not a breakout. Nice. So what are we going to do here? Okay, good. We got this code along. I'm going to see if they're going to do. No, okay. I think the rest of the lesson is just this code along. I believe that's the case. Memory serves. Okay. So there's this little exercise that I like to do, build a word frequency dictionary. And before we start the code along, I'm going to show you the word frequency dictionary. So here's our test text. This function print word frequency dict. We'll take in text with a T, and def word frequency dict. I'll just do txt and an empty dictionary. So I'm going to split the text into words. And then I can say d sub word equals, let's do this, words list equals text dot split. And then we'll count, words list dot count word. So we can do this. So sometimes you can get away with doing this. This is nice and easy. We're going to do some redundant work technically here, because if we encounter the same word more than once, we'll add it in there more than once, but it's going to have the same count. So we can get away with doing this, even though this is a little bit redundant, but that's fine. Return D, right? So what if I wanted to also make a dictionary where the sort of flipped, where the the values are, oops, and you know what? Let's do this. I'm just going to grab, because we could also clean the text, but I'm just going to assume that we're going to have clean text. We'll just do this on already clean text. So this has the punctuation removed, and then I'll say dot lower here, which will lowercase it. So we're just going to assume like clean standardized text here, right? So what if I wanted to do something else where I have like frequency of word dictionary, which might be, so my expectation for this one, instead of having the word and then its frequency next to it, what if I wanted to have the frequency as a key and then a list of words that all have that frequency? It'll help to have word frequency dict this way. So if I say def frequency word dict, we'll take in text, and I'll call this WF dict equals word frequency dict text. Okay. Let's make a test for this. So I'm not going to write out the full expectation for this because there's a number of words here, and yeah, just in the interest of clarity and time. I can say for word freak in WF dict if frequency not in D, and I need D equals an empty dictionary. Okay, so this is my target. This is my accumulator target, D. So if the frequency is not in D.keys, it'll actually work to just do D, but I like to be explicit, so I always do D.keys. So if the frequency is not a key in the dictionary, then we want to say D sub frequency equals now there's a few ways we can do this. I'm going to do an empty list, and then we'll say D sub freak dot append word. We'll do that. And then at the end of this, we'll return D. Cool. Too many values to unpack. Oh, right. Dot items. In order to get keys and values from a dictionary, when you're iterating through a dictionary, you have to do dot items. If you iterate straight through the dictionary, just like this, you're actually just going to get keys, which is kind of weird, but that's how it works. So if you want to get keys and values, you have to do dot items. Okay. Okay, so this dictionary, let's just look at this, is going to be structured a little differently. So we have a key of 1. These are all the words that show up only once. Is that, do we only have 1s and 2s? Get out of town. I thought we had other ones. Ones and 2s. Okay, whatever. Let's look at the full body of this text. Okay, that should give us something better to look at. Okay. Okay, so now we can do this. Okay, cool. Well, okay. Be OCD about it. Okay, so this is what we get. We have our numbers and our keys here, right? So the output doesn't as much matter, but what I wanted to show is there's certain scenarios where we can get away with doing something like this. We have a dictionary. We can just say, you know, we want to add in, you know, for this key, we want to add this value. So something important to remember with dictionaries is you can't have an orphaned key without a value, and you can't have an orphaned value without a key. If you delete the key, the value goes with it, and vice versa. So, well, I think if you fully delete a value, that you're going to get an error because it'll be like, hey, I have a key that doesn't refer to anything. You know, what does that even mean? So, sometimes you can get away with just doing this in a line, right? Sometimes you have to have different logic for adding in a new key that's not in the dictionary. So this adds in, I think about this as adding in a new key, right? Now it adds in a new key value pair. So this is for if a key is not in the dictionary, where do we want to initialize it? And there's a number of ways to do this, right? I kind of like this way. Another way is to do else. And since else is now an alternative and this won't run, we have to add in word when we first initialize it, right? So yeah. Yeah, so yeah, that works that way too. And then we have a question here. Can I walk through the logic of all this in order? Yes, I would love to. So I'm going to do this solution. You're welcome. Let's delete this. So in order, in terms of the way the information flows, right? We have this, I'm going to consider this cleaned text. It doesn't have any punctuation or anything like that, and it's all lowercase. And we're passing it to our frequency word dictionary, which gives us the frequency and then the word. Or the frequency and then a list of words that have that frequency. So that's going to be represented as text. First thing we do here is in this frequency word dict is we call word frequency dict and save it into a variable here. So the way word frequency dict works is this is a pretty, what I would consider a pretty straightforward accumulator. And why did I think I was going to do something there that I didn't do. Okay, I don't even need that line. So empty dictionary, and then we have to add in key value pairs. So in this case, we can just do that because we have the count method. For word in text.split gives me a list of words because it splits on spaces, and that's how we in English and let's say most other human written natural languages delimit words is with a space, right? So we just use that as a delimiter for the list as well. So we'll iterate through every word. And then for every word, we'll say d subword equals word.count word. Now, there is a way to do this without using .count. And it's the same way as below. I just wanted to kind of juxtapose the two ways. We could say if word not and d dot keys. Then we'll add it, we'll say d subword equals, word list. Oh, that's why I had it that way, right? Because I did use it twice. So d subword equals, we'll say 1, because we know we've encountered that word once. And then we could do else d subword plus equals 1. We could get rid of the else, pull this out, and make this equal to 0. That way we can increment it. The first time we increment 0 to 1, it represents the correct value. Okay. So this is another example. So what I'm trying to show here, and I'll actually do this the .count way. What I'm trying to show here is that you sometimes you need to delineate in your mind, am I adding, when you're accumulating into a dictionary, you're either accumulating a key value pair into the dictionary, or you're accumulating onto a value that is at a key, right? So you can use, I'll give you an example of that second one here, right? D equals dictionary. Let's say A, 0. Oops. B, 0. C, right? So I could say, for, well, I mean, I can alter each of these values. So let's just print D, and I could say D sub A, D sub A plus equals 1. Print D again, right? So I can accumulate onto the key value pair directly, or I can accumulate, and you can see, sorry, there's a bunch of output, but it's these last two right here, right? So we can see A, the number at A was accumulated on, right? So the keys themselves can be targets. In this case, and this is not uncommon, I mean, maybe it's even typical. In this case, we start with an empty dictionary, so we know we have to accumulate keys and values. We have to accumulate key value pairs, which is what we're doing here. And we're also accumulating, so the values are lists. We start those as empty lists. So the key value pairs themselves are accumulation targets, right? So we're, so this is like a dictionary where each key value pair is in essence an accumulation target as well. So we not only have to accumulate the key value pairs, but we accumulate into the values as well. It's not uncommon that you'll do both. It sounds complicated, but all you have to do is remember, check if the key that you want to add is not a member of the dictionary, and if it's not, then add it. That's all you have to do. There's a number of ways to lay out this control flow. This is kind of my preferred way. Just say like, hey, if it's not in there, then add it, and then go about your business as if it were in there, because it is. Now it is, right? So just have that line that makes sure that the key that you want to alter is in there, and then you should be good. Like I said, though, sometimes you can get away with just not doing that, just doing this directly. Okay, so back to in order. So here's our data, our call, our invocation, which invokes the prior function, empty dictionary. I'm just saving this word list as its own variable because I wanna iterate through it and do count on it, just so I don't do split twice. Split is not a super heavy operation, but like, why do it twice? Why not just capture the list? And then forward, here's the iterating through it, and then we add the key value pair. And in this case, we can just get away with just adding the key value pair every time. We're going to do some, I mean, technically it's going to encounter the same word more than once a couple times, but who cares, right? Like it's going to give us the same dictionary whether we avoid this with control flow or not, and this is just simpler code, so it works out in this case. And then we come back to here, so we have our word frequency dict, we have our empty target for key and value, which I'm calling word and frequency, in wfdict.items, that's our word frequency. And then here, again, we check if the key is not a member. If it's not a member, we add it in, initialize it with an empty list. Sure looks like the start of an accumulator pattern to me right here. And then we accumulate onto that empty list that we just created. Unless it is already in there, then we have the frequency, so we know how to locate that list and just append right to it. Cool. Hopefully that's a good walkthrough, like end to end, of what's going on there. Let me know if anybody's got any additional questions for that as well. Why are you looking for dup frequency and not dup words? Not sure I understand. Let's see though. Yeah, duplicate, yeah. Can you sync your code into GitHub? I don't have the like live share script that Tovio does to sync immediately. I need to like set that up, but I will share this in Slack really quick. Line 115, I will look at line 115. You're welcome. Line 115. So I'm looking for duplicate 116. No worries, that's fine. I probably changed it to so if frequency not in d.keys. So this is so the way I'm reading your question, and I might okay. Why not word here? Because I want to add frequency as the key. So frequency word dictionary has a dictionary where the keys are integers representing the frequency, and the values are a list of words that have that frequency. Word frequency dictionary is a word and is a dictionary where the words are the keys and the values are the frequency, an integer representing the frequency. So what I'm doing here is I'm iterating through a dictionary of word frequency, and I'm constructing a dictionary of frequency list of words with that frequency. So so I check if the thing that I want to be the key, which is frequency. So I want the frequency to be the key. So I check if that is a member of this, right? And then you were asking about, it seems like you're clarified on that. So you were asking about duplicates I'm not sure. Are you clear on that aspect of it as well? Okay, cool. Good. Yeah. Yeah. So again, I mean, I know I just said this, but I mean, this is fine that we're taking time to explore this, because I had to learn this the hard way. I had to learn, I had to develop this from scratch. Like, when I was taught dictionary accumulators, it was like, oh, okay, there's a dictionary, you can accumulate on it, and that's it. And that's all it was just like, here's a bunch of types, go accumulate. And I was just kind of thrown to the wolves. And after many times of like, okay, I got to write a dictionary accumulator. Oh no, what? And I would, kind of bang my head against the problem until I realized, oh, every time I figure this problem out from scratch, I'm doing this thing where I check if the key, and I would like, it would be like an epiphany every time, that I would have to do it. And I'd be like, oh, if I check to see if the key is a member of the dictionary first, then I can add it in, and then I can go about my business altering that key, so this pattern will save your life one day, perhaps. I don't know. It'll make things easier. I wish I had been told this rather than having to figure it out every single time from scratch. So yeah, just keep in mind. I mean, there's a myriad of different patterns, that are different ways that similar patterns might look different, right? But so there could be variations on this that might not feel the same. But if you keep it in the back of your mind when you're adding things into a dictionary, ask yourself, are you adding something to a key that already exists, or are you adding fully a new key value pair, right? So it takes that question in the back of your mind to to manage keys and values together. And if you keep that question, if am I altering something that exists, a key value pair that exists, or do I need to make sure it exists first? Do I need to add in a new key value pair as well? If you keep that in the back of your mind, you'll be saved a lot of work that I had to go through for you. So you're welcome. Okay, cool. Let's actually go through. So I wanted to do that. I wanted to do this little code along before we got into the other code alongs here, to illustrate this exact point that was just asked about, that I've just been talking about. Key value pairs take sort of some deliberate attention to managing. Let's jump into the code along. I think there's 2 code alongs here. We might not get through both of them, but that's okay. I think this one actually was better than better to do anyways. Okay, so write a function that will, for any given string, return a dictionary that gives us the number of vowels, the number of non-vowels, and the number of non-alpha characters. So this does kind of sound familiar. It does kind of sound like this problem. Yeah. So let's see here. I forget what they called this. You gonna see it? Okay, whatever. I missed it. Okay. So let's call this, who wants to name this function quickly before I think of a name? Dictionator. That's the Dictionator now. Char count, that's way better. char count. So I'm going to call it char count D for dictionary. Often, if my function returns a list or dictionary, I'll put list or dictionary or dict or D in the name of the function. Cool. So char count dictionary. We'll take in text. Now, I assume some of you, I assume you have the material in front of you, so you could scroll down and answer this question I'm about to ask, but what's our dictionary look like? And think about this, right? So this is saying for any given string, return a dictionary that gives us the number of vowels, number of non-vowel characters, the number of non-alpha characters. So what should our dictionary look like? Should we start an empty dictionary? I know it's a very leading question, and you have the answer right there. But think about it. Think about it anyways, even if you've seen the answer. Right, so this is a little different than the problems that I just showed. Right up here, in either case, in either one of the examples that both of the functions that I made here, I'm starting an empty dictionary and accumulating from scratch. In this case, I have the categories that I want like already laid out for me. So number of vowels, we'll assume that we start at 0. Oh my gosh. And then it's number of number of vowels, number of non-vowels. We'll assume that's also 0. And number of non-alpha, also 0. Cool. Nice justified code. Okay. So we already have our categories, and a lot of times you have a problem where you're like arranging things into categories. Well, dictionary is kind of perfect for that. So we have our categories already laid out for us. So we can just seed this, and I can already tell, unless something changes in a future slide, if we adhere to this guideline as our problem statement, essentially, we don't need to accumulate any other new keys. So this is actually good variation on the theme from what we were just looking at, where here we don't need to accumulate new keys at all. We're just accumulating into the vowels, right? So I would barely even think of this as a dictionary accumulator. This is really an integer accumulator problem. It's like if I had or let's do this. Imagine if I had an accumulator pattern problem where I said, oops, oh gosh. If I just had 3 variables as integers, like you'd call this an integer accumulator pattern problem. And this is, that's basically how we're going to treat it. It's just that those integers happen to be members of dictionaries instead of their own independent variables. Okay, so we want to iterate through the letters, so or the characters for character in text, and I'm going to do txt because that's what I like to do. For character in text, we can say if character dot if character in vowels, So if character in vowels, wait, A, E, I, O, U. So if character dot lower in A, E, I, O, U, then we know D sub vowels plus equals 1. And then from here, it's just control flow. LF, I mean, I guess we can just say else. Else, non-vowels plus equals 1. Actually, you're gonna have a space in here. Why don't I have, let's use this opportunity to use spaces because this looks a little nicer than underscores like that. Okay. So D sub vowels plus equals 1, else D sub non-vowels plus equals 1. We can do that. And then non-alpha characters. So there's a string method. So if I said ch dot is alpha, this returns true or false when the character is an alpha character, non-alpha characters. Yeah. So what I can say is if not ch dot is alpha, because when it's an alpha character, I don't want to add 1 to non-alpha. So we'll say D sub non-alpha plus equals 1. So if it's true that ch is alpha, we don't want to add it. If so, therefore, when ch is alpha is false, we do want to add it. We want ch dot is alpha. We want this condition to be true. So I'm just going to invert this condition with a not, right? Because I want this condition to be true when is alpha is false and false when is alpha is true. So I'm just going to invert its output with not by putting not in front of it. So if not, ch dot is alpha non-alpha plus equals 1. Cool. And let's just see. Well, you can go through the code along there, but I think it's easier to just do it this way. They do this. They take this approach. I mean, if you're wondering why they didn't go through the material directly, is they kind of take this approach where I think they start with the dictionary and then they do the conditions with passes and then the consequence of those conditions without having the ch from the for loop, and then they wrap it all up into a function. The way that I prefer to work, and I feel strongly about this, is almost exactly the opposite of that workflow. So yeah, I do it this way instead. That way we start with a test. We have some idea of what we expect, even if we don't have a full expectation written. And then, we'll start with the dictionary, go through the for loop, and then do one condition to completion at a time. And that's my preference. But so the order that I place things and the order that I write my code in is generally pretty deliberate, and I want you to pay attention to that as we work together. I haven't explicitly talked about this as much, but I generally like to start with a test, which is this portion here. A test involves some specific piece of data that we're going to test on, and an invocation. If we're returning, then I'm printing out the function that I'm going to write. And if it's easy, if it's not going to take a whole lot of time or effort, then I'll be as clear about an expectation of a result as I can be, right? So usually I'll just take a comment and in this case, say this should be a dictionary with these 3 values, and I won't write them out, but I might write those out and put some number just to give me an idea about something that I should return. So I'll start with that, and then I'll write in my, usually it's an accumulator pattern that I'm working on, so I'll write in my target and return it, and then fill in the middle of the function. And I find that to be much easier in terms of dealing with everything. Cool. All right. So that's a wrap for today. Let me